This is a video on Edexcel C1 topic 1, so about the Earth, sea and atmosphere. So it begins talking about the early atmosphere, moving on to how the atmosphere changed, and then how we have the current atmosphere, and also how we can investigate the amount of oxygen we have in the current atmosphere. It's a pretty short video. It's a pretty short topic. There isn't that much in terms of a lot of factual information, a lot of common questions that come up time and time again. So make sure you know this area pretty well. So the early atmosphere was formed of gases from volcanic activity. Okay, if they ever ask what formed the early atmosphere, it's gases from volcanoes, from volcanic activity. They might ask about the composition. It had little oxygen, large amounts of carbon dioxide, water vapor, and a small amount of some other gases. There's limited evidence, this is a key thing over here, there's limited evidence about the early atmosphere, therefore it's difficult to be precise about how the atmosphere changed over time. So this statement over here is a good answer if they ever ask why are we unsure about how the atmosphere changed over time, and the answer is because there's limited evidence. Much of it has been destroyed. Scientists believe that volcanoes gave out a large amount of the carbon dioxide and also possibly nitrogen that was stored inside, but definitely a lot of water vapor. So this large amount of carbon dioxide and water vapor came out of those volcanoes. Now if the Earth is going to cool down, condensation will take place, and that will turn that water vapor into liquid water, and that's what made the oceans and the seas. The atmosphere also has a small amount of, also may have had a small amount of methane and ammonia, so that's where we think the nitrogen went into forming that ammonia. So the atmosphere changed from this point. The way it changed was that a large amount, almost half that carbon dioxide atmosphere, dissolved into the oceans, okay, into newly formed, into coral life, into mussels, into starfish, okay, so into marine life that lived within the oceans. It incorporated into the shells of those. So where we have carbonate rocks, that's where it ended up being. So when these died, fell down to the bottom of the ocean, and you end up with sedimentary rock there. That's where that carbon dioxide ended up. Plant life is key though in the change in atmosphere. Plant life took in carbon dioxide because of photosynthesis. So if they ever ask how carbon dioxide level decreased, it's because plants photosynthesize, taking in carbon dioxide. Okay. Remember, they also therefore add oxygen to the atmosphere. That's the role of plants in the changing atmosphere. The current atmosphere, well, the experimental setup we have over here can be used to investigate the current atmosphere. This is a slow experiment because we're leaving it over time. You could use a similar one but without water, instead using a syringe with some markings on it that say how much gas is in there, and you heat it up to speed up the experiment. In this one we've got wet wool, moist or steel wool in here at the end of the test tube. That's going to rust over time, and it will take in the oxygen from the air that's in the test tube. Now, if that test tube is 100 milliliters long, then 21% of that will get taken away. So it'll be 79% of that will be left, and the water will be sucked up in its place. The reason why is because 21% of the air in there is oxygen. So this could be asked about in the exam, so make sure you understand what's going on there. The BBC Bitesize website is an excellent example of a gas syringe, where they heat up some copper, and a similar thing happens there, where 21% of the gas in the air disappears. So due to this process highlighted above, so that's photosynthesis, volcanic activity, formation of the oceans, the composition has drastically changed, and the pie chart to the right shows what the modern day atmosphere is like. 21% oxygen, and 78% nitrogen. They're the two main ones. Other gases are about 0.0%, so you've got argon, carbon dioxide is a very, very small amount right now. Small changes in numbers occur, mainly due to volcanic activity. Small changes due to volcanic activity and the activity of humans. Sometimes deforestation, burning fossil fuels, and farming can all change the percentage as well. Deforestation means there's fewer trees, less carbon dioxide taken in. Burning fossil fuels increase the amount of carbon monoxide, sulfur dioxide in the atmosphere by burning these fuels that contain carbon and sulfur. And the engines of cars also releasing nitrogen oxides. Farming produces large amounts of methane, especially from cattle farming and rice fields. And that's the absolute basics you need to know about topic 1 the Earth's sea and atmosphere. So make sure you know what the atmosphere used to be like, how it changed, what it's like now, and experiments to do with how we can investigate how much oxygen there is in the atmosphere.